Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 6.3 Future Values of Annuities. Let us look first to this application. Twins graduate from college together and start their careers. Twin 1 invests $2,000 at the end of each of 8 years in an account that earns 10% compounded annually. Notice that he invests $2,000 at the end of each year, and that we have 8 years and compounded 10% compounded annually. After the initial 8 years, no additional contributions are made, but the investment continues to earn 10% compounded annually. So in the first 8 years, he puts 2,000 each year, 2,000 each year. So you can say he puts in the account 2,000 times 8, 16,000. And then after that, he doesn't put anything. But the amount stays in the account, and uh, it continues, it earns 10% compounded annually. So this is the investment plan of Twin 1. Twin 2 invests no money for 8 years. So in the first 8 years, he doesn't do anything. But after 8 years, he contributes $2,000 at the end of each year. Notice that also at the end, for a period of 36 years to age 65. So this means that 36 plus 8, 44. Uh, so they have now 21 years old. They are 21 years old now, and this is their plan. So Twin 2 will not put anything for 8 years, but when he reaches 29 years old, he will start putting 2,000 each year for 36 years. So he will put in the account 2,000 times 36, he will put 72,000 in the account. And the account pays 10% compounded annually. How much money does each twin have at age 65? So twin 1 will put 2,000 for 8 years, so he will put only 16,000 in the account, but the account will work for 8 years and 36 years, so the account will work for 44 years. While twin 2 will not put anything for 8 years, but he will put 2,000 each year for 36 years, so he will put 72,000 in the account. So which one of them will get more money at the age of 65? We will answer this question after we talk about annuities, because putting 2,000 each year for 8 years at the end of each year, or putting 2,000 at the end of each year for 36 years, this is what we call ordinary annuity. So ordinary annuity, we will talk about it first, and then we will talk about annuities due. What is the ordinary annuity? Yeah, it is this one, the thing twin 1 and twin 2 does or did. Most people save or invest money by depositing. You deposit small amount at different times. Okay. If a depositor makes equal deposits at regular intervals means each year, each month, each week, okay, equal deposits, he or she is contributing to an annuity. So what is the annuity? equal deposits at regular intervals. This is annuity. The deposits or payments may be made weekly, monthly, quarterly, yearly, or at any other interval of time. The sum of all payments plus all interest earned is called the future amount of the annuity. Okay, so adding all the payments plus all the interest earned, future amount of the annuity. So we would like here to see what is the future amount of the annuity for twin 1 and what's the future amount of the annuity for twin 2. So we will deal with annuities and this text in which the payments begin and end on fixed dates. Okay, fixed dates, beginning of each month, end of each year, something like this. First, we will deal with annuities in which the payments are made at the end of each of the equal payment intervals, and this is what we call ordinary annuity or annuity immediate. And after that, we will consider uh, the beginning of each of the equal payment intervals, and that's called annuity due. So let us take the formula of the future value of an ordinary annuity. How to find the future value of ordinary annuity? This is the formula. S is the future value. Okay, S is the future value of an ordinary annuity. R is the deposit. Okay, R is the deposit each month, each year, at the end of each period for n periods. So n is the number of periods, not number of years, okay? Number of periods in an annuity that earns interest at a rate of I per period. So what is I? I is the interest rate per period. So if the period is month, each month, okay? So I is, as we know, R over M. We divide R, the annual rate, by the number of compounded monthly. If monthly, you divide M is 12. If quarterly, M is 4, and so on. So to find the future value of the annuity, you multiply R times 1 plus I all to the power n number of periods minus 1 over I, the interest rates per period. You get the future value of the annuity. So let us find the future value for twin 2. Okay, twin 2 doesn't invest anything for the first 8 years, but then he invests 2,000 at the end of each year. At the end, so we use this formula immediately, the ordinary annuity. For how long? 36 years. So 2,000 is what? Is R, the deposit. That's the deposit, okay? At the end of each year, so yearly, he deposits yearly for 36 years. So how many periods are there? 36 years. So N is 36. In an account that pays 10% compounded annually. Okay. Uh, Notice that always compounded annually, and he puts the deposits each year. We will consider only these types of annuities. So this is R, and it is also I in this case because he puts the deposits each year. So I is zero point 0.1 over 1 or just zero point 0.1, which is R. How much does twin 2 have at age 65? So let us find the future value of this annuity. R is 2000 times 1 plus I. 1 plus zero point 0.1 means 1.1. 1 plus zero point 0.1 is 1.1. Okay, 1 plus I 1 plus zero point 0.1, which is 1.1, to the power n 36 minus 1. All right. So 1 plus I, 1.1 to the power n minus 1 over I, which is zero point 0.1. Okay. Multiply, use the calculator, multiply 2000 times 1.1 to the power 36 minus 1 over zero point 0.1. The answer is 598,253.61 dollars. So $598,000. This is what twin 2 will have at the age of 65. What about twin 1? Twin 1 invests 2,000 at the end of each of 8 years in an account that earns 10% compounded annually. So this is the annuity. This is the ordinary annuity. So let us find the future value of the ordinary annuity in this case. 2000 is R times 1 plus I, again I is zero point 0.1, but here to the power 8 because only 8 years, minus 1 over I, which is zero point 0.1. Now, if you multiply this to the power 8, okay, the answer is 22,871.78 dollars. Now this amount of money, he will not put anything more, so there is no annuity, but this investment will continue to earn 10% compounded annually for 36 more years. So what do we have now? We have a usual investment compounded annually. So what is the formula we use? This is the future value given by P, 1 plus I to the power n. This is the formula in the previous section, section 6.2, because there is no annuity here. He will not put any money. This amount of money will work in the bank for how long? 36 years. Okay. So the future value of 22,871 would be what? P, which is the principal in this case, times 1 plus I. I is zero point 0.1 again, because 10% compounded annually. So 1.1 to the power n, which is 36. And if you multiply, the answer would be 707,027.91 dollars. 707,007 dollars. It's greater than this amount, of course. This is 598,000. This is 707,000. So this is much more, twin 1. Although he contributes only for 16, he paid only 16,000. Yeah, but why? Because his amount of money worked more. Okay, but twin 2 did not put anything in the first 8 years. So the time is important, and this is what twin 1 and twin 2 will have at the age of 65. And twin 1 here, his investment is better and more greater than twin 2. Okay, a small business invests 1,000 at the end of each month. So I just okay. So 1,000 is what? Is R, the deposits, each month. So 12 times per year. in an account that earns 6%, this is R, compounded monthly, of course, monthly. So what is I? R is 1000. What is I? I is 0.06. This is 6% over 12. Okay, because I is the interest per period, and the period here is monthly. So I is 0.005. How long will it take? Okay, so he's asking about N here. How long will it take until the business has 100,000? Okay, so this is the future value. So the future value is given 100,000 toward the purchase of its own office building. Okay, so we have 100,000. This is equal to 1000 R times 1 plus I, which is 1 plus 0.005 or 0.005 to the power n, which is unknown, minus 1 over I, which is 0.005. So that's always the formula. 1 plus I to the power n minus 1 over I. Now, how to solve this equation for n? Well, let me first divide by 1000. When I divide by 1000, I'll have both sides. I'll have 100 equals 1.005 to the power n minus 1 over 0.005. Now I can multiply cross product. So I can multiply the 100 times 0.005. So I'll get zero point 0.5. So zero point 0.5 is equal to 1.005 to the power n minus 1. Now if I take 1 to the other side, I'll have 1.005 to the power n equals 1.5. Now how to solve this equation for n? I apply ln to both sides. And then I use the properties of ln to write n here before the ln. And then n would be, I divide by ln 1.005 and just divide ln 1.5 by ln 1.005, and the answer is 81.295, so it would be 0.3. What? This is the number of periods. What is the period here? Months. So 81.3 months. Okay. So now how to answer the question? How much? The answer is how much, how long will it take? So it will take, it will take 81.3 months, or just say 82 months. 82 months, okay? Because if you want to keep it in months, so after 82 months, we will have 100,000, the future value. Okay, sinking funds. What is sinking funds? Sinking funds is the amount, the deposits, okay? The deposits you save. Consumers who are saving for an unanticipated purchase, something they want to buy using regular savings plan. So sinking funds, regular saving plan to obtain some specified future amount. Okay. So for example, he wants to buy a car with 100,000 real. So he will save a regular saving, a regular deposits. Okay. So periodic deposit. he will put a periodic deposit, then after some time, some number of periods, he will get the future amount. So here we know the future amount, but we need to find the deposits. So it's the same formula, the same rule, but now he will give you S and you need to find R. So to find R, you divide S by this and you get R, the deposit. So the deposit in this case is called sinking funds. So it's sinking funds when we know the future amount that we need, okay? And we need to find the periodic deposits at the end of. So a company establishes a sinking fund to discharge a debt of 300,000 due in 5 years. So we know that the debt is 305,000. This is the future value, and in 5 years they need to pay this debt by making equal semi-annual deposits. Semi-annual means twice a year. Okay, twice a year, each 6 months. The first due in 6 months. So at the end of the first 6 months. If the deposits are placed in an account that pays 6%, so they will put the deposits in an account that pays 6% compounded semi-annually. So what is I? 0.06 over 2, 2 times per year equals 0.03. So this is I. And what is N in this case? The number of periods, 5 years, twice a year. So 2 times 5 is 10. 2 times 5 is 10. That's in the number of periods. You multiply uh, M times T, if you remember, M times T. If the deposits, okay, that's it. What do we need to find? What is the size of the deposits? So we need to find R. So we write the formula 300,000 equals R, which is unknown, times 1 plus I, so it's 1.03 to the power n, which is 10, minus 1 over I, which is 0.03. So you can solve it as you wish, okay? For example, yeah, I'll just find R immediately. I will divide this by this. And find the answer. Okay, you can write it in the calculator like this: 300,000 over, you can put fraction again and write 1.03 to the power 10 minus 1 over 0.03, and the answer is 26169.15 dollars. So these are the deposits they have to put, the equal deposits they have to put in the account semi-annually, twice a year for 5 years, to get after 5 years the amount of the debt, which is $300,000. Suppose that $500 is deposited at the end of every quarter. End of, this is an ordinary uh, annuity. 500, this is R. Every quarter, so 4 times a year. 6 years. So what is the total number of payments periods? N. 4 times 6, 24. 6 years and 4 times per year. What is the interest rate per period? I. Well, it is R, 8%, compounded quarterly 4 times a year. So it's 0.02. That's I. What formula is used to find the future value of the annuity? The future value of the annuity is S. It is R times 1 plus I to the power n minus 1 over I. That's the formula. Find the future value of the annuity. R is 500. 1 plus I, 1 plus zero point zero 0.02 is 1.02 to the power n, which is 24, minus 1 over I, which is 0.02. And if you use the calculator, the answer will be 152, 110.93. So 15,210. That's the answer. A sinking fund of 100,000, so this is the future value, is to be established with equal payments at the end of each half year. So twice a year for 15 years. So N is 30. Find the amount of each payment. So this is R we need to find. If money is worth 10%, compounded semi-annually twice. So 0.05. So to find R, S would be S, which is 100,000 equals R times 1 plus I, so it's 1.05 to the power 30 minus 1 over 0.05. Just divide minus 1 over 0.05, and the answer is 1,505.14 dollar. So that's the answer, the deposit. Find the future value of an ordinary annuity of 8,000. So this is R, paid quarterly 4 times for 3 years. So N is 4 times 3, which is 12. If the interest rate is 8%, compounded quarterly, I divide by 4. So find S. S would be 8,000 times 1 plus 0.02 to the power n minus 1 over 0.02. And the answer would be 107,296.72 dollar. The white man's wants to save $40,000 in 2 years. So this is the future value for a down payment on a house. He needs 40,000 after 2 years. If they make monthly, they need. If they make monthly deposits, how many times per year? 12. So what is N? 12 times 2, 2 years, 24. What is I? 0.12, paying 12% compounded monthly. So 0.12 over 12, that's 0.01. This is the interest rate per period. What is the size of the payment? He is asking about R that are required to meet their goal. So 40,000, okay, that's the future value, equals R times 1 plus I, which is 1.01 to the power 24 minus 1 over 0.01. And then R would be you divide, use the calculator, and the answer would be 1482.94 dollars. So this is the deposit, the monthly deposit, $1,482. If 2,500 is deposited, so this is R, at the end of each quarter, so 4 times a year, in an account that earns 5%. So I is 0.05 over 4 compounded quarterly, and the answer is 0.0125. After how many quarters? Okay, so N is required here. Will the account contain 80,000? So this is the future value. So 80,000 equals R, which is 2,500, times 1 plus this number to the power N, which is unknown, minus 1 over 0.0125. Okay. I can divide 2,500 over 0.0125. Okay. I will get 200,000. And then I divide the 80,000 in the left hand side by this number. And then I will get 2 over 5 or zero point 0.4. So zero point 0.4 would be equal to 1.0125 to the power n minus 1. Okay, so I divided these two numbers, this by this, and then I divided 80,000 by this number. So I will get this equation. And now if I take 1 to the other side, I will have 1.0125 n equals 1.4. And then if I use len as I did before, I will have n len 1.0125 equals len 4, and then n would be len 4 over len 1.0125, and that's 111. Okay, this is there is something. This is len 1.4. I wrote len 4, sorry, 1.4. Yeah, the answer is 27.09 watt. Periods. What is the period here? Quarter. Okay. He said how many quarters? So 27.09. But we will say what? How many quarters? After 28 quarters. You cannot say 27 because after 27 quarters, the amount 80,000 will not be in the account because you need 27.1 quarters for 80,000. After 28 quarters, you will have 80,000 and even more. Okay, but 80,000 would be after 28 quarters. So this should be your answer. You always round up to answer the question. $4,000, which is R, is deposited at the end of each half year twice a year in an account that earns 6.2%. So I 6.2 divided by 100 is 0.062. Okay, how many times? 2 semi-annually, twice a year. So 0.062 divided by 2 is 0.031, isn't it? How long will it take? Will it be? Okay, so he's asking about n again. Before the account contains this is S. So 120,000 equals R, which is 4,000, multiplied by 1 plus I, which is 1.031, to the power n minus 1 over 0.031. This time I will do the following. I will multiply 100, 120, 120,000 by 0.031 and then divide by 4,000. Okay, can do whatever you like. I did three different methods. So 0.93 would be equal to 1.031 to the power n minus 1. And then 1.031 to the power n would be 1.93. This means n is ln 1.93 over ln 1.031. So divide ln 1.93 by ln 1.031. The answer is 21.54. What is this now? 21.54 what? Semi-annually, half years. Okay, half years. So which means 22 half years. So 22 half years or 11 years. Okay, so after 11 years, we will have 120 120,000 in the account after 11 years. This is all about ordinary annuity, and I hope that you understand it uh, carefully now. You understand it completely.